Good day! In today's lesson, we will work on solving one more system. We previously discussed that the solutions of the system are specific values that fulfill all inequalities. I want to emphasize that a system of inequalities includes several inequalities. At this point, we will only look at two inequalities within the system. Although the system can contain 3, 4, or more inequalities. However, for now, we will work on the following system. 2, y value is lesser than 8, and y minus 6 is larger than 3. How do we solve this system? We mentioned that to solve a system of inequalities, we need to first tackle each inequality separately. The first inequality first, and then the second one. And we will perform the final step when we discover the intersection of these two solutions. Let's illustrate this with an example. We will solve the first inequality together. 2 multiplied by y is below 8. To solve this inequality, I have to divide both sides by 2. What results from this? 2y. I should divide by 2. I divide less than 8 by 2. Now let's solve the second inequality. Y minus 6 is more than 3. In this case, we move 6 to the right side, resulting in 3 plus 6. Let's continue solving the inequality. Dividing 2 by 2 gives us y. 8 over 2 is 4. Y is less than 4. But the value of y exceeds 9. What happens in this case? Let's demonstrate the solution of these inequalities on a number line. Let's start by writing the first inequality, y4. And on the number line, we will illustrate the solution to this inequality. We will denote the point 4 and show all the values that fall below 4. I like to illustrate this and shade this interval like this, using these lines. Now I will show the solution to the second inequality. I have y greater than 9. I will indicate the number 9 on the number line. 9 is an empty point on the line. All values greater than 9 are a range, which is located to the right of the number 9. Now we will proceed to the final step. We will merge these solutions together. Imagine overlaying one number line onto another. What happens in this case? As a result, I find one solution on one number line, that is below 4. The second solution is the number 9, and the interval that lies to the right. And in this case, we see that the solution to one inequality is all values less than 4. And the second inequality's solution includes all numbers over 9. Yet, we observe that these solutions do not overlap. Therefore, I can conclude that our system has no solutions. Or, as it's said in mathematics, this is an empty set. What does this empty set mean? That in interval and concurrently in the second interval, I cannot find a number that is simultaneously less than 4 but greater than 9. For example, if I choose a number greater than 9, for instance the number 10, indeed 10 is greater than 9, that's correct. However, the number 10 is not less than 4. Similarly, we can verify a number that is less than 4. for instance, the number 2. If I use the number 2 into the first inequality, 2 is less than 4. Yes, that's true. But if I substitute the same number into the second inequality, 2 is greater than 9. This is an incorrect statement. I cannot find a number that is simultaneously less than 4 but greater than 9. In such cases, mathematicians write that the system of inequalities has no solutions, or they are recorded as an empty set. Thus, solving systems of linear inequalities, you may not always find an answer as an interval. Some systems have an empty set as their solution. Next time, we will tackle another system of inequalities. For now, our lesson is over. Farewell, until we meet again.